Hi, and thanks for watching this video, which is about programming in C on the Oric one. I started off actually trying to see if I could convert programs I'd already written in my own programming language called Dflat. And this is a program called Lander, and it's written in Dflat, as you can see on this screen here. And the idea is to land your spacecraft on the base without hitting anything else. And it's Dflat is an interpreted language with also an inline assembler, so it's a bit like BBC Basic. But let me quickly show you what Dflat Lander looks like. So, so you can see it's quite a simple concept. Just try to avoid obstacles. Let's see if I can actually get somewhere with it. So the idea is I need to navigate this screen and try and get to the bottom right, and then try not to hit anything and make a soft landing, which I just about managed there, probably on the border of doing it. And each time you manage to succeed, you have more obstacles on the next page. So it's a pretty simple game. And there's a bit of flickering because it's built in this. That was too fast. I was too fast to land there. It's too heavy. So, but that's the idea. So let's see how we could write this in C. And the way to do that is on the. If I just hide that screen and show you the browser, there's something called OSDK, the Oric Software Development Kit. And essentially, it's a bunch of tools and utilities that allows you to program the Oric in C language and also actually in assembly and mix the two things together. And what you can see here is the home page, so it's osdk.org, and some excellent folks have pulled all this together. You can go to the download section where the current version, which is 1.21 as of today, and it was last updated in April 25, so it's still being maintained. And the download section allows you to download OSDK for the Oric 1.21, and in the documentation section you get information about how to install and set up the system. And it's basically a Windows command prompt driven set of scripts that compiles your C programs and assembly programs and then links them. So you have to set up an environment variable. That's the main thing that you need, which is this OSDK variable here, and then run it under the command prompt. So that's the I'm not taking you through this in detail, of course, but essentially it's all here on this brilliant resource, osdk.org. And then once you've unpacked that download, if you open Visual Studio Code, you'll eventually end up in you'll see some folders here. Let's not worry about the all of this other stuff for the moment. But when you open it in the folder that you did download, you'll get these directories, and the main one is this one called sample, where there's C samples, and I've copied one of these C samples into something called Lander, and then I've taken my Lander program, which is this one that you're seeing here. This is the one that the Dflat game that I just showed you was running. So this is, as you can see, it's a bit like sort of C/Pascal style. And it's also got an inline assembler. So as I said, it's a bit like BBC Basic. The assembler routines are needed just to speed up things like collision checking and plotting the small spaceship a little bit more smoothly. So not too many lines of assembly. Also some data statements to define the graphics basically. And if I show you on the original Dflat that I just showed you a second ago, let me break into the program and list it out. Some of the graphics have been redefined, but essentially you can see that's the program that we're showing you in VS Code. And that's, if I type start, initializing the assembly, and then it goes into the screen that you saw. So that's basically what I'm trying to rewrite. And my main.c essentially contains the main program. I've also got a main.asm. That's where I'm putting the assembly stuff, like the plotting of the ship. I've converted all that over from the PRG file, and it wasn't too hard because it's structured in a C-like style. I was able to bring across routines and then rewrite them quite easily because the logic, I didn't have to really think too hard about how to structure the logic. Because I have for loops, I have repeat until loops, I have do loops, etc., which easily convert to C. And actually Copilot with the kind of autocomplete in VS Code takes pretty good guesses from Dflat into C, so that's quite handy. So all of this code is converted from the PRG. The good thing is that when you have an assembly program, you can, so for example, plot ship is a C function, which is declared as a C function, so I can call it from C. But in my assembler file, as long as I have underscore plot ship, the linker successfully recognizes that as this function here, then I can call plot ship in my C code. In addition, to make the porting easier, Dflat uses custom graphics routines, which are much faster than the Oric ROM. So I also ported those over from my assembler ROM source code, and essentially just ported that over, and more or less came over pretty straightforward. So these are the two assembly files that get assembled along with the main, and I've got routines like grh plots, and that basically plots a high resolution character on the high resolution screen at pixel down to pixel level, and it's optimized. It's much faster than the Oric's built-in routines. I also added a keyboard scanning routine, which is again optimized to allow me to get the cursor keys for input. So just down here, got my stick assembly routine, and that gives me faster access to keyboard scanning. So I did all of that, and then the way to build it is by, once you're in the command prompt with the right environment variable, you type OSDK build, and it runs the compiler and the assembler, links it all together, and essentially gives you a TAP file, which is the Oric's tape file format, which I can now then download, run in an emulator. So if I do OSDK execute, that will just run the emulator. So let's do that, and also make it visible. There we go. So let's look at that compared to the original Dflat. So you can see it's kind of similar. I've made a couple of color enhancements, but basically it's the same program. I'm using mostly the same approach. So let's play this one and see how it looks. So it's a little bit smoother. I actually had to put some delays in to make it work like this, otherwise it would be too fast. But you can see it's oh, well, that's annoying. I thought I was going to get there. But you can see it kind of works very similar. So let's have one more go, just so I can actually get across the screen without killing the spaceship. So the idea is not to be going too fast. Yes, 122 because you get points based on how much fuel you still got left when you successfully land. And then the next page has got even more obstacles. And let's see if I can land this one as well. No, but I did also add a high score feature, which wasn't in the Dflat version. And I forgot, so I haven't changed the title. It says Oric Lander in Dflat, which is actually not true. It's Oric Lander in C. So I'm going to definitely change that before I upload the source code to GitHub. But hopefully that gives you a bit of an idea of how we can program in C on an Oric, compile and run that. And of course that tap file that is produced by all of this can be converted into an audio output, and then you can load that into a real Oric. And I didn't show that here, but you trust me, you can definitely do that. So I hope that was an interesting, useful overview for anybody who wants to try and program their Oric in C. Thanks for watching.